Good day, Ram. I'm going to discuss about stress concentration. Stress concentrations occur at sections where the cross-sectional area are suddenly changes. We're going to use two formulas. K is equals to sigma maximum over sigma average. And to find the value of sigma average, we could use force P over cross-sectional area A. These are the charts that can allow us to predict or estimate the value of the maximum stress. So figure 4-23 is used in the fillet, and figure 4-24 is used in the hole. Sample problem 1. Determine the maximum normal stress developed in the bar when it is subjected to a tension of P equals to 8 kN. So we have this figure. We have P is equals to 8 kN and we need to find the maximum normal stress. Next, we're going to list down all the required values. For the fillet, we need width, radius, height, and thickness. To find those values, we need to look at this part. The width is equals to 40 millimeter. The height is equals to 20 millimeter. The thickness is equals to 5 millimeter. And our radius is equals to 10 millimeter. And for the hole, we're going to look at this part. The width is also 40 millimeter. Our 2R is equals to 20 millimeter. And our thickness is also 5 millimeter. The formula we needed is 2. First, we're going to find the value of K. So in the fillet, we have width over height and radius over height. Since we already have the value of width over height and radius over height, we're going to find the value of K through the chart. So here, we have R over H as 0.5 here, and width over height equals to 2. This curve and 0.5 intersect here. So our value of K would be 1.4. Based from the chart, our value of K is 1.4. Since we already have now the value of K, we could solve already for the maximum normal stress in the fillet. So this formula came from the chart. Moving forward, we're going to solve for the hole. And for the hole, we need to find the value of radius over width to find the value of K. Our 2R is equals to 20 millimeter over 40 millimeter. We have 2R over W as 0.5 here. So our value of K is 2.1. Since our K is 2.1, we could now solve for the maximum normal stress in the hole. That is our maximum normal stress. Sample problem 2. Determine the maximum force P that can be applied to the specimen. The bar is made from steel and has an allowable stress of 150 megapascal. Allowable stress is equals to maximum stress, which is equals to 150 megapascal, and we need to find the maximum value of P. So we're going to list down all the required values. For the fillet, we need width, radius, height, and thickness. For that part, we're going to look at this. So our width is 150 millimeter. Our height is 50 millimeter. Radius is equals to 20 millimeter. And for our thickness is 6 millimeter. And for the part of the hole, we're going to look at this part since the hole is there. Our width would become 50 millimeter. The value of 2R is equals to 5 millimeter, and our thickness is 6 millimeter also. We're going to solve for the value of K in the part of hole. So 2R over W is equals to 5 millimeter over 50 millimeter is equals to 0.1. So to determine the value of K, we're going to use the chart. Since 2R over W is 0.1, going off, intersecting the curve, the value of our K is 2.64. Since we already have the value of K, which is 2.64, we can now solve for the value of force P. Substituting all the given values, allowable stress, value of K, the width minus 2R, and the thickness, leaving force P on the left side. So we could have force P is equals to or 15.340 kilonewton. Next, for the fillet, width over height and radius over height. So 150 millimeter over 50 millimeter is equals to 3.0, and 20 millimeter over 50 millimeter is equals to 0.4. Looking at the chart, since R over H is 0.4 and width over height is equals to 3, the second curve a value of K is within there. So K is equals to 1.52. Given the value of K is equals to 1.52, we could now solve for the value of force P in the fillet. So substituting all the values, the given values, we have the maximum stress, the K, the height, and the thickness of the bar. Isolating the value of force P on the left side, we could have the value of P as 29.605 kilonewton. The force in the fillet is 29.605 kilonewton. And for the force in the hole, we have 15,340 kilonewton. And we are asking what is the maximum value of P that can be applied on the bar. So we're talking about the maximum value applicable to both fillet and hole of the bar. So we're going to choose the 15.340 kilonewton. Hope you learned. So job well done, Ram.